Hey guys, 7th grade task for 7th grade. This is on theoretical probability of simple events. So this is different than experimental probability of simple events, just slightly different. Okay. Theoretical probability is the probability that an event occurs when all the outcomes of the experiment are equally likely. The formula is really no different. It's the probability of an event to occur. You need to divide the number of ways that you want this event to occur, divided by the total number of ways that it can occur. For example, let's say I've got a number cube like this, and I want to know what's the probability of me rolling a 3 or a 4. Well, you've got 1 3 and you've got 1 4. So you've got two numbers. You've got two numbers out of 6. So the probability of rolling a 3 or 4 is 2 out of 6. And in lowest terms, that would be 1/3. So, or 33% chance. Okay, that's it. What about rolling an even number from a number cube? Well, I've got 2. Where's 2 at? I've got 2, 4, and 6. 2, 4, and 6. I've got 3 numbers that are even. So 3 out of 6 total numbers are even. So that's going to be 1/2 in lowest terms, or 50%. And it says picking an ace from a deck of cards. Well, a deck of cards has got 4 different suits. And I didn't have a deck of cards to share with you. You've got diamonds. You've got spades. Got clubs. Ooh, I don't know if we can do clubs very well. Clubs, and then you've got hearts. Well, an ace, you've only got 1 of each kind. Okay? So you've got 4 aces. 4 aces out of how many cards? 52. And in lowest terms, that's 1 out of 13, which makes sense because there's 13 cards in each suit, right? There's 13 cards in each suit. So that means 1 out of 13 is an ace, which makes sense. 1 out of 13, it's going to be, let's see, 1 divided by 13 equals about 7.7. You say where it says we're going to move it to the right 2 places. So 7.6923%. Let's say 7.7%. Around 7.7%. And that's it. Let's do a couple more examples. So let's say we have a jar that contains 8 red marbles and 2 blue ones and yellow ones. 10 yellow ones. Now, what's the probability of me getting a red marble? Well, there's 8. Right? Well, 8 out of what? Well, 8 out of the total. How many total marbles you got? 8 plus 10 is 18. 18 plus 10 is 28. So it's going to be 28 total. In lowest terms, that would be, let's see, I divide this by 4, I get 2. Divide this by 4, I get 7. So you can say it's 2 out of 7. And that's fine. If you want to change that to a percentage, 2 divided by 7 equals 0.2857142. Move it to the right 2 places. The decimal, so it's about 28.6%-ish. Some will say 28.6% would be fine. Some would even say about 29%. Honestly, somewhere in that range is fine. I'm not going to complain about that. Blue marble. You've got 10 blue marbles. So 10 out of the same number, 28. Put that in lowest terms. It's going to be 5 out of... See, divide that by 2, you get 5. That's true. To divide this by 2, you get 14. Alright, so I can't reduce that any further. So it's 5 out of 14. If you want to change it to a percentage, take 5 divided by 14. And that equals about... let me change it to squiggly lines here. Roughly about 35.7%. And then yellow marble, we've got 10, 10 out of 28. And lowest terms, oh, same thing. I was like, wait a minute, that's exactly like the blue. Yeah, it is. Anyways, so again, that's going to be 35.7%. And if you were to add up all of those, if you were to add up all the percentages, okay, you should get about 100%. Okay, I'm not going to do that now because of time. All right, let's move on to another one. One more. All right, let's say we picked marbles out of a jar and we put them back in. You know, every time we pulled one out, we put it back in, but we recorded it. So let's say I did it 40 times. Okay, out of a total of 40 times, I believe. How many? Let's see. Yeah, this is 30 combined. This is 10 more, so that's 40. Okay, so that's 40 times. Now the question is, how does this line up with me theoretically thinking about it? Like, you know, just saying, hey, look, we got 8 red marbles, we got 28 total. What is the probability of me getting a red? Well, we said 29%, right? Well, let's see if this lines up with what we did in real life. So this is what we're doing, is we're basically comparing theoretical probability with experimental probability. This is what we actually done, supposedly. Of course, this is a simulation that I didn't do with you, but imagine with me, okay? So 14, so the probability of me getting a red was actually 14 out of 40. Because remember, there's 40 total marbles. The blue was 16 out of 40. The yellow was 10 out of 40. Well, if you put those in lowest terms, if you want, or you can just simply divide them. Sorry about that, I didn't realize it was on document camera. Or you can just simply divide the top by the bottom, you can do that. I'm just going to simplify it just a little bit. So this is going to be 7 over 20. This is going to be 8. Well, wait a minute. 8 over 20, but I can actually go a little bit further. I can divide this by 4 to get 2. Divide this by 4 to get 5. This is 1/4, basically. So 1/4 we know is 25%. 2/5 is going to be 40%. And then this one's going to be 35%. Okay. So if you take a look, again, with the same amount of marbles, but this is what happened when we actually did it. We had 35%. If you look up here, it says theoretically we're supposed to only have it for about 29%. So this is a little bit higher than, right? Higher than our probability, higher than our theoretical, right? Here, this one's 40. Blue says, we should get about 35.7, close to 36%. But when we actually did it, we got 40%. This one higher. What's the chances of you thinking of this getting higher too? Not likely. If both went higher, you know, again, remember, you got to add this together to create 100%. This is probably going to be lower. So you can compare it to your theoretical probability. Hey, we're supposed to get this about the same amount, 36% of the time, but we got way less, like 11% less. This went down. So the reason why I bring this up is, now this ain't, I don't think this is in your homework. This is like maybe a really difficult question to respond to. I think this is a hot topic, actually, a higher order thinking question. The reason why this is important is just to show you that theoretical probability, before we actually even do it, when we think about it, when we theorize and think of our chances, and they better be equally likely, right? These marbles are all the same size. We don't know their color, okay? It's in a jar. We can't see it, obviously. But when we actually do it, this is what happens. So this is what we call, again, experimental probability. This is experimental. Right? Using experience, using actually data, collecting data of what we actually done, simulating it here. And you can see it doesn't always line up. So experimental and theoretical won't always line up, but I can promise you this. The more that you do this, right, the many more times, 40 times is not going to be enough. But let's say I did this, not 40 times, but 1,000 times. If I did this 1,000 times, I can guarantee you that this 35% is going to go down closer and closer and closer to 29%. And this 40%, same thing. This 25% is going to increase. It's going to get closer and closer to that 35%. It won't be exact. Okay, they'll never quite line up exactly the same, but they'll get closer to each other the more times you do it. Okay, hopefully that makes sense. Guys, if you have any questions, please email me or catch me on Zoom. Other than that, I'll catch you in the next video. God bless, and Godspeed.